Hello, today I'm going to go over the notes for lesson 5-4, and this is going over more proofs for congruent triangles. So you can see at the top we have 4 ways to prove triangles congruent: side, 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 angle, angle, and angle, angle, side. We're going to use one of those 4 ways in each of the proofs for this lesson today. So not only the notes but the homework, we'll all use them. So at some point you're going to use each of those, and for a couple of these on the notes and then some for your homework, you're also going to use CPC-TC, which is congruent, corresponding parts of congruent triangles are congruent. So let's see what we have here in example 1. We were given this information: QS bisects angle PQR, and angle PSQ is congruent to angle RSQ. So let me go ahead and copy that down. Segment QS bisects angle PQR, and angle PSQ is congruent to angle RSQ. I'm going to go ahead and mark those. So PSQ is right here, RSQ is right here. Those are congruent to each other. And then I also know from the fact that segment QS is bisecting angle PQR that I'm going to end up getting 2 congruent angles out of that, each of them half as big as the original angle PQR. So I have my first statement. My first reason is always given. The first statement, keep in mind, is always the one you're provided with. And then what am I trying to prove? I'm just going to go ahead and write it in there. I'm going to try to prove that triangle PQS is congruent to angle RQS. So I'm going to go ahead and write that in there as well, just to know where I'm going in this process. So the first thing really is they told you that these, about the segment the angle bisector. QS bisects angle PQR. So I went ahead and modified my drawing. I marked it up, but I didn't actually write that down in my proof yet. So I need to go ahead and make sure that's included in my proof. So angle PQS is congruent to the other one, and that's RQS, angle RQS. And how do I know that? That's from the definition of angle bisector. Okay, then what am I trying to do next? Well, I need to eventually prove that these triangles are congruent. So I already have what? Angle and another angle. So I have 2 angles. The only thing I really lack is some kind of side. I either need angle, angle, side, or angle, side, angle. Well, the answer lies right here. They share a side. So this is one of those instances where you're actually going to, when they share a side or share an angle or share anything, you're going to end up saying something like this. Segment SQ is congruent to itself. So segment SQ is congruent to segment SQ. And how can I say that? Reflexive, sorry, I spelled that wrong. Reflexive property. Might as well write the whole word out this first time. So I'm using the reflexive property to say something is congruent to itself. Now that I have done that, I have angle, side, angle. So that's a single arc, a single slash, a double arc. Over here it's the same thing. Single arc, single slash, double arc. So I can go ahead and say my 2 triangles are congruent. Because of why? Because of angle, side, angle. Because of that congruence proof for proving two triangles are congruent. Okay, so that was a pretty short proof. This one's a little bit longer, not a whole lot. In example 2, we are told a couple of things. V is the midpoint of segment YW. So if it's the midpoint, I know those two segments are going to end up being congruent. I need to still write that in my proof though. And I also am told that segment UY is parallel to segment XW. So I'm going to go ahead and write that all down. V is the midpoint. YW. And then segment UY is parallel to segment XW. The reason I know that it was given. And what am I trying to prove? I'm trying to prove triangle UVY is congruent to triangle XVW. Okay, so that's all I can really do so far without actually doing any geometry work. So the first thing I'm probably going to start with is what I already marked. I already know V is the midpoint of YW. So because of that, I can make the conclusion, as I already did, that segment YV is congruent to segment VW. How do I know that? That's just because of the definition of midpoint. Okay, definition of midpoint tells you when you have a midpoint, on either side of the midpoint you have two congruent segments. Then what I need to do next is I'm really going to use the other part of that given statement, which was that we had parallel lines. Parallel segments. Segment UY and segment WX are parallel. Well, what does that mean? I have actually two transversals. I'm going to deal with one at a time. This transversal actually ends up creating alternate interior angles. So I can go ahead and write that down. And I'm going to have to use, I guess you don't have to, but it's probably for the best if you use full names for this. So I'm going to say angle YUV is congruent to angle, let's say that's WXV. How do I know that? Because of the alternate interior angles theorem. A lot of abbreviations there. Okay, well, is that the only transversal I had? I had another one. So that means we have another pair of alternate interior angles once again. And notice by doing that, now I have angle, angle, side, angle, angle, side. So that is why I went in that direction. So what are the angles I just talked about? Angle UYV is congruent to the other one, which is XWV. Oops, that was a V. And how do I know that? Same reason. In fact, some people may feel tempted to put this as one double statement and just write the reason one time, because it really is the same reason. In some proofs you might actually see that. Instead of breaking it down into two separate statements, it might be one big statement. And then we already know what we're trying to prove. We're trying to prove triangle UVY is congruent to triangle XVW. First of all, is that true? U and X are the first letters. They have a single arc. V is the next one for each. And that would be, you can tell these are vertical angles, so these two angles would have to be congruent. And then Y over here has a double arc. W has a double arc here. So, and not only that, but we also have the sides that are congruent to each other, which we already talked about. So how do we, this is a true congruent statement. And how do we know that? Because we have angle, angle, side. Angle, angle, side. And we're going in the same order. Single arc, double arc, single slash. Single arc, double arc, single slash. So the reason I know those two triangles are congruent is because of angle, angle, side congruence. So those are the first two examples. If you flip over the notes to the second page for 5.4, you'll be reminded about CPC-TC. Corresponding parts of congruent triangles are congruent. And this is really not too different than before. What we did on the first page, we're going to do again, but we're going to do one more step. So in a proof for CPC-TC, as it says, you need to first prove that the triangles are congruent. And you're going to do that the same way we just did, using one of those 4 ways. After you do that, usually immediately after, then you will say, well, if I know the two triangles are congruent, one part of the first triangle is congruent to the corresponding part of the second triangle. And that'll usually be your final statement. And it'll usually be preceded by this statement, the SSS or so on. So that's usually how it works. Those are usually going to be the last two statements or reasons. Okay, so what are we going to do first? We have this problem. Oh, and the problem with this figure is extremely hard to make sense of because you have two triangles overlaid with each other. So I'm going to end up having to use some color coding to help with this. But let me just copy down what I'm given. Angle DAC is congruent to angle BEC. And also these two segments, DC and BC. Those are congruent to each other. I know that because I'm given, and what am I trying to prove? That angle EBC is congruent to angle ADC. Those are the 3 things I can write down straight away. Okay, let me try to mark up what I was given. And I'm going to do this the best I can without trying to make it even harder to read. I was given the information that angle DAC is congruent to angle BEC. BEC, that's over here. Okay, so far so good. That was not too bad. And then I know that segment DC, I'm going to color code this with a marker, is congruent to angle BC. Segment BC. Those two segments are congruent to each other. So besides the marker, I'm going to use my single slash to indicate that they're congruent. And what do we have here? We have angle, side, and angle, side. Notice they both have something in common. Besides overlapping a little bit on the sides, the most obvious other thing they have in common is they both share angle C. So that ends up giving me angle, side, angle, and angle, side, angle. So what I'm going to do is use the reflexive property to say angle C is congruent to angle C. And that is just the reflexive property. Anytime you say something is equal to itself, that's the reflexive property talking. Well, what am I trying to do now? I'm trying to eventually prove these two angles are congruent. So let me look at those angles real quick. EBC, that's right here, and then ADC, that's right here. So I have two different angles, one angle in each triangle. And the best way to prove that those are congruent is to first prove that the triangles themselves are congruent. So I'm going to say triangle EBC is congruent to another triangle. Okay, now I need to be careful with my congruent statement. EBC. I'm going from single arc to no arc to double arc. How do I do that on the other? That's single arc A to no arc D to double arc, which is C. So triangle EBC is congruent to triangle ADC. How did I know that? I've already said it, but it's angle, side, angle, and then angle, side, angle. That's all I need. Oh, let me see. Did I do that wrong? Angle, side. Okay, I figured out what I did wrong. The thing I did wrong was exactly what I warned you about at the very beginning. This thing that I said has a single slash is really for the green part, but that's not the entire leg of this whole bottom leg. I actually have, let me get a different color here. I actually have a whole leg spanning this side and a whole leg spanning over here. Those have not been proven to be congruent yet. At least not at this point. So what did I have? I had let's see, for this triangle AD, let's go with the order that we were given. EBC. So I have not talked about this side yet, but I do have angle, okay, angle E, angle C, and this side BC. That's angle, angle, side. And let me see if I have that. So I started with a single arc, double arc, and then the single slash. The other thing I have, okay, so that was a single arc, okay, so yeah, sorry, I went double, sorry, single arc, double arc, and then single slash. Sorry, I got interrupted. Single arc, double arc, single slash. So how do I do that? I'm going to say A, angle, angle, side. So I have angle, angle, side both ways. I can say angle, angle, side, or angle, angle, side. Yeah, this one is really my least favorite problem to teach because it is so easy to get confused. That's why you almost have to have color coding to help you with this. Okay, the good thing is once you have done that, the next step is extremely easy. How do I then know that angle EBC, which I have not yet marked, by the way, is congruent to angle ADC? Well, those are just corresponding parts. See, each of those angles is the unmarked one. Angle ADC hasn't been marked, and neither has EBC. So those are definitely corresponding parts. And we've already established that these triangles are congruent. So corresponding parts of congruent triangles are congruent. CPCTC. Notice how I proved in the second to last reason that the triangles are congruent. And in the last step, I'm saying CPC-TC. That's usually how it's going to be. Example 4 will be much easier than example 3. Example 3, like I said, is quite confusing, and we don't usually give you one that confusing. But anyway, let's see what example 4 says. KH bisects angle GHJ. That's very similar to what we started off the notes with. So segment KH, KH is bisecting angle GHJ. And then you have angle G is congruent to angle J. So angle G and angle J, let's go with the bisecting one, go in order. GHJ is being bisected by KH. So if there's bisecting, that means GHJ is being split into two congruent angles. The other thing I was told is angle G is congruent to angle J. Well, you can probably see what's coming next, but we're almost there, proving these two triangles are congruent. So anyway, what do I wrote down my given. What's the reason? Because it was given. What am I trying to prove? Simply that segment GK is congruent to segment JK. Okay, let's see how I can do this. First of all, I've already marked this, but I haven't written it down. That segment bisector, or sorry, the angle bisector. I know angle GHJ was divided into two congruent angles. And what are those two congruent angles? GHK, angle GHK, is going to be congruent to angle JHK. And that's simply the definition of angle bisector. And we just used that earlier in this video. Okay, then what? The next one's probably pretty obvious by now. We have angle, 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 angle. If we had a side, we would be perfect. Well, what's the obvious choice of a side? The reflexive side. So KH, segment KH, is actually part of both triangles, which is why it's relevant. So we're going to say KH in one triangle is congruent to KH in the other triangle, and that is just the reflexive property. Now we have enough. We have angle, angle, side. So that's double arc, single slash. Angle, angle, side. Also double arc, single slash. So I can go ahead and say, I'm going to use an angle, angle, side to say triangle G. It really doesn't matter how you do this, but I'm going to just say angle GKH. And once I write down this side, I need to be consistent on the right side. GKH. So I went from double arc to no arc to single arc. Double arc is J, no arc is K, single arc is H. So triangle GKH is congruent to triangle JKH. And what did I use again? Angle, angle, side, angle, angle, side. So that's my reason. Okay, now look at what we're trying to prove. Segment GK is congruent to segment JK. Are those corresponding parts? We've already established these two triangles are congruent, but are these corresponding parts? Well, I'm going from a single arc to no arc. Sorry, from a double arc to no arc, and from a double arc to no arc. So they are indeed corresponding parts. So GK is congruent to JK because corresponding parts of congruent triangles are congruent, or CPC-TC. So whenever you have one of these proofs, whenever you're trying to prove that parts of congruent triangles are congruent, you're going to use CPC-TC as your final reason almost every single time. I don't have any exceptions that I've come across. And the one right before that is going to be some kind of reason to prove why those triangles are congruent. Because once you've established they're congruent, you can talk about their parts being congruent. So it immediately follows.